Yes. All right, so we are here with period 4, ready to learn about dividing polynomials. Last week, we finished the week by looking at solving by factoring for some x-intercepts, and ultimately learning how to write the equation of a polynomial based on the graph. We talked about multiplicity. Remember, like double roots, triple roots? Those words might sound familiar if you were here last week. And we also talked about end behavior. You know, how the end of the functions look, whether they're both going up, both going down, one in either direction. So we'll be bringing that back next week as we get ready for our test at the end of next week. All right, so what we're going to focus on today is one skill, dividing polynomials. There's 2 ways to do it. Long division, which will be this video, the first half of class, and then synthetic division. Hopefully, since I taught, I think almost all of you in Algebra 2, you will remember synthetic division. We did that together. All right, so I'm hoping this will be a quick refresher. So when we need to do this later on this week, when I ask you to find slant asymptotes, you'll be able to know how to divide. Slant asymptotes. Yeah, you gotta do it like that. Nice, Emmanuel. Yeah, everybody. Okay, let's practice like we're gonna be at Six Flags. Okay, ready? So when I say this way, we're gonna act like the ride is going that way. So your body goes that way. Right? We're gonna use some gravity here. Okay. All right, ready? So when I say slant, you're all gonna slant to your right. Your right. Not yet. When I say slant, ready? Just be careful. When I say that word, that's when you need to go to the right. All right, slant. You didn't do it. All right. This time we're going to slant to the other way, to your left, this way. All right, when I say that word, S-L-A-N-T, you're going to go that way. All right, when I say the word, when I slant! There. All right. So let's start with this division problem. I have 6x cubed plus 11x squared minus 31x plus 15. That's going to go inside the house or barn or whatever your 5th grade teacher taught you. And 3x minus 2 is on the outside. Do you guys remember what these are called? Do you remember what goes on the inside underneath here, what that's called? The quotient is going to be the answer. That's going to go up here, Sylvester. So we are looking for the quotient. Dividend. Very good. That's the dividend. Do you know what this one is? Divisor. Very good. Nice. One of my math teacher in 5th grade, she said that think of like the oars on a boat. They go on the outside of the boat when you row the boat. Divisor, oar, like on the outside. You don't know what an oar is? Now, look, see how much you've learned today, and Aiden missed out on that? All right. Let's go ahead and ask ourselves first, what am I going to write up here? Here we go. What am I going to write up here that's going to multiply by 3x and give me 6x cubed? 2x squared. Now, it's my preference, and you can write it wherever you want. I prefer to write it above the same power. Do you see how I wrote the square above the square? That's my preference. It's up to you on where you write it. Some students will write it at the beginning. Whatever you want. Doesn't matter. I just like to write it above the same power. My preference. All right, so what is 2x squared times 3x? 6x cubed. Guys, if those are not the same, then we've already made a mistake. All right, so that's your first kind of mental check. That better be the same. Now, there's something else out here, this minus 2, that I need to multiply by. What is 2x squared times minus 2? Negative 4x squared. Do you remember what operation you do with the black terms and the purple terms? You subtract. Very good. All right, so I'm going to subtract. How did I get the negative 4? So this 2x squared has to multiply by both terms in the divisor. So I multiplied it by both terms in the divisor, and in purple have what happens when you multiply. All right, now that should be 0, right? 6x cubed minus 6x cubed should be 0 every time. Every time you do this, that should be 0. So that's gone. So really it comes down to, I know I'm going to have x squared here. What is 11 minus negative 4? So no, because 11 minus a negative is really adding, so it becomes 15x squared. I'm going to pause here. Questions? You can know.
No, I was going to say it's
For the 15x squared? Whenever we get to this step, Andriana, when it's subtraction, we know that these will not change. What changes is the numbers in front. Those are called the coefficients. The coefficients change. All right, I'm going to bring down the rest of my terms. So I'm going to bring down minus 31x plus 15. I used to always think of this when I was in elementary school, like I've got a piece of wood and I'm whittling it down to make a rocking chair. All right, so we're slowly carving this piece of wood, and it's going to be smaller and smaller until it's gone, until we have a chair. All right, no more just piece of wood, now it's a chair. Or a table, right? Get crazy. Okay, now, what are we going to multiply now times 3x to get 15x squared? 5x. And because you didn't say negative, I'm going to write plus 5x. All right, so what is 5x times 3x? Right, and that should be the same every time, right? It should always match there. If it doesn't, you've done something wrong. What is 5x times negative 2? All right, and we are going to do the same operation as before, subtraction. So we know that's going to be 0. So now I have negative 31x minus negative 10x. Negative 21x, very good. And we're going to bring down the 15. Okay, pause here. Any questions so far? How did I choose 5x? So you're asking your brain, if I want to get 15x squared, what term is going to multiply by 3x and give me 15x squared? So 5 times 3 is 15. X times x is x squared. All right. Okay, the last step. What am I going to multiply by 3x to get negative 21x? Very good. So I heard negative 7. All right, so negative 7 times 3x is negative 21x. What is negative 7 times negative 2? Positive 14. And the operation that I'm doing is subtraction. So I know that's 0. What's 15 minus 14? 1. So my remainder is 1. Does anybody remember from your algebra or pre-cal days what I do with that remainder? So that would be if you were in 5th grade, you put, I didn't mean that to be, sorry, it sounded like I was being mean. That's what you did in elementary school. You did R1. But that's not actually what mathematically you should write anymore because you guys are not 5th graders. So what should we write with that 1? Do you remember? Over what? Not over 100. It is over something plus over the divisor. That was me rowing. I know it was weird. No, that was me rowing. I don't go on boats. It's clear. Okay? Now, here's what conceptually you need to know about this. All right? You just divided this dividend by this divisor and got this quotient in purple. So the answer is in purple. All right? But if you were to go backwards, take the purple and multiply it by the divisor, you would get the dividend. And that's what you learn in elementary school, that division and multiplication are inverse operations. All right? It's the same idea, But now we have polynomials. It's much more challenging. Are there any questions about long division? Because you're about to try this on your own. Yes, Jalissa. Yes, the answer is in purple. Purple is answer. Now, you'll notice in my dividend, did I have any missing terms in terms of the exponents? So I went cubed, squared to the first power, and then constant. You see I went in order there? What if I was missing one? Because you're about to do some on your own. What if I was missing one? You're not missing one there. You're not missing one here, but what would you put if you were missing one? 0, whatever it is. So let's say I didn't have x squared. I would have written plus 0x squared. Okay? So make sure you put a placeholder. Let's call it a placeholder. Yes, Jalissa. Mm-hmm. So I need 3 to become 6. So 3 times 2 is 6. And then I need x to become x cubed. X times x squared is x cubed. Any other questions? Okay, let me make sure. I think I made a mistake, so I want to make sure that if I tell you